Hi scholars, today we're going to talk about factoring quadratic expressions. And again, this shows up in a bunch of different areas of mathematics where it's important to be able to do this and do this quickly and without any errors. So first off, what does it mean to factor an expression? And what it means is it really means to rewrite as a product. Okay, so for example, a simple one would be 3x plus 6, and I can rewrite that. Right now, this thing is a sum, right? And what I could do is I can actually rewrite this as a product of 3 times x plus 2. And going from here to here, this is factoring. That's what it means to factor, because I'm rewriting it instead of a sum now. I'm rewriting it as a product, right, of two different expressions. Okay, and here's the big idea. Factoring is like the reverse of multiplying. Okay, so if I go from this direction to this direction, all right, if I'm multiplying two binomials, that is multiplying, and if I go in the reverse direction, that is called factoring. Okay, so I'm rewriting this thing that has all the plus signs, I'm rewriting this sum as a product of two binomials. So let's take a look at a couple examples. Let's find the product here. So this is a review from multiplying two binomials together. So we can do our FOIL method, or we can reason about double distributing, and any way you want to do it, as long as you get the right answer. We're going to get x squared plus 5x plus 2x plus 10, which is x squared plus 7x plus 10. So this is our answer when we multiply it. And we've seen before that there is this sort of pattern, right, where if I look at these numbers 5 and 2, or positive 5 and positive 2, and I say the sum of these numbers, so if I do 5 plus 2, well, that's equal to 7. Well, there's a 7 right there. And if I say the product of these numbers, that'd be like 5 times 2, well, that's equal to 10. And there's a 10 right there. Okay, so this sum product pattern can be used to very quickly factor trinomial expressions. So again, this is the sum, here, we'll just do it in black. This is the sum product pattern. Okay, so if I wanted to factor this thing, well, here, look, we already know the answer, right? We know that the answer is x plus 5 times x plus 2, right? Because we just went and we just multiplied it out. So it's just factoring is the reverse of multiplying. But if I didn't know that, I would look and I would ask myself, what two numbers, if I add them together, I get 7? And what two numbers, the same two numbers, if I multiply them, I get 10, right? Positive 7 and positive 10. And those are my answers, 5 and 2. So let's take a look at a couple more examples. So let's factor x squared plus 6x minus 16. Okay, well, my first term is x squared, so I know that whatever this thing looks like, it's going to look like an x here and an x here. And now, if I look at the middle term is positive, which means that and then I look at the last term is negative. So again, this is representing the sum, and this last term, the negative 16, and that's a negative 16, is representing the product. And since it's a negative number, the product is a negative number, I know that whatever my answer is, I'm going to have a negative and a positive, because that's the only way when I multiply them to get a negative number. Since the sum is positive, or is a positive number, the coefficient is plus 6, I know that this number, the positive one, right here, is going to be the larger number. Okay, and then I want to think about what two numbers would add to 6, multiply to negative 16, and it's 8 and negative 2. Okay, and so we factored it, x minus 2, x plus 8, and if you want, you can check by multiplying it back out, and you'll get the same answer right here. Let's factor this one, x squared minus 6x minus 16. Okay, so we start the same way. We have our x and our x. We see that the product is negative 16, so we're going to have, since it's negative, we're going to have, here, we'll just do it in the same order. We're going to have one negative and one positive. Okay, and then we want to look at the middle term, and we see that here the sum is -6. So that means that whatever value is in here is going to be larger than the value in here because there's more negative going into that middle term, right? Being added to that middle term. So we think about what two numbers multiply to be -16 and add to be -6. And again, it's has to do with 8 and 2, only this time, right? The 8 is the one that's negative. So it's -8 and +2. And that's how we would factor this expression. Okay. Let's take a look at this one. And so was our last question we're going to go over. And we may ask ourselves, what is the point of factoring? Who cares? And the answer is it allows us to solve quadratic equations, okay, using what is called the zero product rule, which we'll go over as we go over this example. So let's say I have x squared plus 6x minus 16 is equal to 0. Solve for x. Okay. Well, I can't just like guess and check here. Say, well, what if x is 1? Let me plug it in. What if x is 2? That would not be a very efficient way of solving for x. I could try to say, let me add 16 to both sides. Then I got x squared plus 6x, right, equals to 16. And let me try to, like, I don't know, divide by x or something like this, and right? You could try to do that, but you're never going to get x all by itself doing this, right? And the reason why is because of that squared term. The squared term is kind of messing things up. If we didn't have the x squared term, this would be a simple linear equation that we could solve in the way that we've always learned how to solve it, right? Adding and dividing and so forth and so on. But since I have a squared term, I have to use it in some way. So so let's start by factoring. Okay, we already factored this one, so that's nice. So this is our x plus 8 and x minus 2, I believe, right? Okay, and now we're going to use our zero product rule. And if we look at the structure of this equation, so here's this equation we have right here. It really has a structure that says I have this one thing, x plus 8. This is one thing. It is one expression. And I'm multiplying it by this other thing, x minus 2. That's one thing. And I get to 0. Well, if I have two numbers, or two values, right? We could call this sort of x's, and okay, it's a little complicated. We call this like a and b, right? If I have a times b equals 0, what do I know for sure? Well, the only way to get to 0 is if either a is 0, because 0 times some number is equal to 0, or b is 0, because some number times 0 is equal to 0, right? There's no other way to multiply two numbers together and get to 0. So we know that either one of these things is 0 or the other one is. So either x plus 8 is equal to 0 or x minus 2 is equal to 0. And then this is nice because we can just solve this, right? Subtract 8 on both sides, and we get that x is equal to -8, or add 2 on both sides, right? And we get that x is equal to 2. So this is interesting. There are two possible solutions, x is equal to -8 or 2. And we can actually take these numbers and plug them back in, substitute them back in to check our work. Okay, this is important. It's important to check one's work. So let's just do it for x equals 2 really quickly. So if x is 2, I would have, is it true that 2 squared plus 6 times 2 minus 16 equals 0? Is that true? This is my check. That's 4 plus 12 minus 16. Is it equal to 0? Yeah, you bet it is, right? That's 16 minus 16. So 2 checks out, and you can do the same with -8. And this is how we solve a quadratic equation, right? First we factor the quadratic, and then we use the zero product rule to say, well, either of these factors, either one or the other of these factors must be equal to 0, and then we just solve our simple linear equation.